Hello guys, welcome back. So myself Assistant Professor Gaurang Prajapati from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari. So in this video we are going to cover the third part of the chapter, that is connection. Okay, in the previous two videos we have covered theoretical portion as well as first design, that is beam to beam web cleat angle connection. Now in this video we are going to cover beam to column web cleat angle connection. Okay, so let's start it with the design. See, a beam ISLB 300 has to be connected to the flange of the column ISHB 300 to transmit an end reaction of 150 kN due to factor loads. Design wave angle connection using M20 poles and 4.6 grade steel Fe410. It has been asked in November 2019 in 7 marks. So in this sum, a beam is there, ISLB 350, it transfers its factor load on the flange of the column, that is this one, ISHB 300. So main beam ISLB 300, column ISHB 300, and reaction, that is 150 kilonewton. Okay, then diameter of the bolt is given M20, so 20 mm diameter bolt. Grade of bolt is also given 4.6 grade, and grade of plate is also given, that is 410 grade bolt. Okay, so as we have done in the previous examples, we are going to do the same procedure for this one. Only one change is there, that is instead of beam to beam connection we are over here doing beam to column connection. So first of all, from IS 800 NXH page number 133, we will calculate, or we will get the value of thickness of web of main beam and width of flange, as well as from the columns property, thickness of flange as well as width of flange. Okay, so main beam is ISLB 300, and okay, so let's do the step by step. First of all, main beam ISLB 300. ISLB 300. Okay, so let's go to the page number 138. Okay, okay, we can see over here ISLB 300. So first of all, thickness of wave, that is 6.7 mm, and width of flange, that will also be needed for the sketch, that is 150 mm. Okay, so this is the data of ISLB 300. Width of flange, that is this one, and thickness of flange, that is this one, 6.7 and 150. Just a minute, let's get back to the sum. See, main beam ISLB thickness of wave 6.7 and width of flange, that is 150 mm. Now do the same thing for the column. See, while it is a column, but the section is obviously, it is a beam section, ISHB, Indian Standard Heavy Beam. So we need to go through ISHB 300. We need to calculate its TF and BF. ISHB 300. Just a minute. Let's search it over here. First of all, ISHB 300, that is over here. We can see this one, ISHB 300. Now thickness of flange and width of flange, we need to calculate these two value, thickness of flange, width of flange. Okay, so column number 4 and column number 5. Okay, see, ISHB 300, column number 4 and 5, this one, we need these two columns value. So width of flange, this one is BF, Fifth column is thickness of wave, that is 10.6. 10.6 is thickness of wave, and BF, that is 250, that is of ISHP 300. Okay. See this one, ISHP 300, thickness of flange, width of flange. So we have used the reference IS 800 NXH page number 138. Okay, so we got these values. Say these values can also be calculated using steel table also. In steel table also you will get all the beam sections property. Okay, like that. Then let's calculate the smaller quantities. That is, first of all, just a minute. See, ultimate tensile strength of the bolt. Bolt is of 4.6 grade, so ultimate tensile strength will be 4 into 100, that is, we can say 400 Newton per mm square. Then talking about the hole diameter, the diameter is given 20 mm. So table number 19, page number 73, 16 to 22 mm range, we need to provide 2 mm extra standard clearance. So DH will be 20 plus 2, that is 22 mm. Okay. Then pitch, that is formula stands for page number 73, formula stands for 2.5 times D, diameter is 20 mm, 2.5 times 20, we got the value 50 mm. And talking about end distance, page number 74, formula stands for 1.7 times DH, DH is 22, so 1.7 times 22, we will get this one, 37.4. let's put down the round figure value, that is 40 mm. Okay, so we have calculated all the parameters regarding the sketch. Now let's do the sum in the previous manner, which we did in the previous sum also, that shear capacity and bearing capacity. Shear capacity in terms of the single shear and bearing capacity in terms of the thickness. So first of all, shear capacity, just a minute. See, shear capacity of the bolt, IS 800, take close number 10.3.3, page number 75. VDSP equals to VNSP divided by gamma MB, where VNSP stands for FU by root 3, and then A and B plus NSASP. Put down this value of VNSP in this formula. So ultimately our main formula becomes this one, VDSP equals to FU by root 3 gamma MB in the bracket and then A and B plus NSASP. Talking about unknown, first of all, FU, that is ultimate tensile strength of bolt, that is 400 Newton per mm square. We have already calculated earlier. Talking about NN, numbers of shear, we are doing this calculation for the single shear, so NN equals to 1 for the single shear. Then A and B, that is net shear area of the bolt, 0.78 pi by 4 d square, diameter is 20, so 0.78 pi by 4 20 square, we got the area 245 mm square. Then NS, numbers of shear planes without the thread, that is always assumed as 0, and ASB don't need to calculate because NS value is 0. And talking about the last one, that is gamma MB, that is partial safety factor, that is always taken as 1.25, which we have already seen in the previous example, IS 800, table number 5, page number 30. Okay, so we got all the unknowns from this one. Let's put down the value over here. FU, that is 400 root 3 gamma MB 1.25 in the bracket, NN, that is 1, A and B, that is 245 plus NS, that is taken as 0. Simplifying this term, we will get the answer 45.3 into 10 raised to 3 Newton. So let's convert it into the kilonewton, that is 45.3 kilonewton. So we got the value of VDSB 45.3 kilonewton. Moving forward, bearing capacity. So the formula of the bearing capacity is on the same page, page number 75, close number 10.3.4. Formula stands for VDSB equals to VNPB divided by VDPB equals to VNPB divided by gamma MB. Value of VNPB is, formula stands for 2.5 times kbdtfu. Let's put down this value in this equation. So ultimately my main formula for VDPB becomes 2.5 times kbdtfu divided by gamma MB. Talking about unknown parameters, see, so first of all let's start with the kb. So usually for HSFZ bolt we usually take the value of kb, that is we can say 1. Okay, but for we can say black bolt, means 4.6 grade bolt, the value of kb usually varies. Say if you are using 16 mm diameter, value of kb is 0.49, and if you are using 20 mm diameter, value of kb is 0.51. So on an average, if we are considering these two value, so we can take the on an average value of the kb equals to 0.5 for 4.6 grade bolt for ordinary bolt, while for HSFG we will always take the value of KB equals to 1. So ultimately right now we are using 4.6 grade bolt, so 4.6 grade bolt we will take the value of KB, that is equals to 0.5. okay, always remember this rule. While if you are using HSFG means 8.8 grade, then value of KB is always taken as 1. okay, so value of KB equals to 0.5 for ordinary bolt. Then second unknown, that is D stands for diameter is there, that is 20 mm. Then T is always keep it as unknown, as we are doing bearing capacity always varies with respect to thickness, and we have two different thickness, one for column and one for beam. That's why FU, that is minimum of ultimate tensile strength of bolt, and grade of plate. So ultimate tensile strength of bolt is 400 and plate of grade is 410, so minimum value will be 400, that is this one. So that's the value of FU. And gamma MB, that is partial safety factor, that is 1.25. clear? So now put down all this value over here. 2.5 times KB 0.5, diameter 20, thickness unknown, FU 400, and gamma MB, that is 1.25. so simplifying this term we will get the value 8000 multiplied by T. okay, so we got VDSB as a singles here, that is value of 45.3 kilonewton, and VDPB, that is 8000 into T. okay, so now let's start the design. So first of all we need to design cleat angle with the main beam. So first of all, just let me take you to the theoretical criteria. See, this one is web cleat angle connection between beam and column. So right now what we are doing, we are connecting first of all with column, for example beam. okay, cleat angle with this beam. So one cleat angle is over here, as another cleat angle will also be over here on the opposite side, which we cannot see from this side. okay, so ultimately talking about the shear, so cleat bolt will be passed first of all from cleat angle, then from secondary beam, or we can say beam, and third then from opposite sides cleat angle also. So bolt will be passing through three medium, so ultimately bolt will be in case of double shear. okay, that is this one. While numbers of bolt may be odd or even anytime. So we have seen over here, see, this is the formula, this is the statement which I have already given in the theory. When cleat angle is connected to the beam, bolts are always in double shear, and numbers of bolt may be odd or even. okay, so let's go to the sum again. See, first of all, main beam is given in the data as LB 300. Just a minute, let me take you over here. See, this one, main beam as LB 300, and thickness of AB is 6.7, which we have derived from IS 800. okay, so see, main beam as LB 300 and thickness of main beam is, we can say, 6.7. Now as we have seen in the theory, the bolt will be subjected to double shear. So first of all, VDSP, that is shear capacity. Bolts are in double shear, we have the single shear value, that is 45.3, so it will be multiplied by 2, so I will get the value, that is, we can say, 90.6 kilonewton. That's the value of shear capacity. Now talking about bearing capacity, VDPB, formula stands for, we have already derived this formula, 8000 into T. Now T stands for thickness of wave, that is 6.7. putting down the over here one editing mistake is there, that is 6.7. okay, so 6.7, 8000 into 6.7, we got the value 53.6 into 10 raised to 3 newton, so 53.6 kilonewton, that is this one. okay, so we have got VDSP 90.6, VDPB 53.6, so minimum of these two value will be subjected to, we can say, bolt value. okay, that minimum value will be obviously this one, that is 53.6. see, so numbers of bolt equals to total reaction divided by bolt value. Now total reaction is given there in the data, that is 150 kilonewton. While talking about bolt value, it is taken as minimum of VDSP and VDPB 90.6, 53.6. so obviously minimum will be 53.6, that is put down over here. Say 150 divided by 53.6, we got the answer, that is 2.8. and over here we have seen already in the theory that numbers of bolt may be odd or even, so we are providing 3 bolts. okay, so and length of the, let's calculate length of the cleat angle as well, as that is n minus 1 multiplied by p plus 2 times n distance. N stands for numbers of bolt, that is 3 we can say. So 3 minus 1, p is already 50, 2 times n distance, that is 40. So we'll get the answer 180 mm. Let's see it in the sketch, just a minute. See this one. So we have connected this one. See, this one is, we can say, beam, okay, and this one is our cleat angle. So numbers of bolt are, we can see there are 3 bolts are there, okay, and these 3 bolts are shown in the side view as this one threads, okay. So now moving forward, second connection, that is step number 2, connection between web cleat and flange of column. Now let's go back to the theory for this one also, just a minute. See, now what we are doing, we are connecting this cleat angle with this flange, okay. So we are connecting cleat angle with this flange of column. So over here we can see only one cleat angle is there, that is this one, okay. There is no cleat angle over this side, okay. So bolt will be passing from first cleat angle, then this flange of the column. So bolt will be passing through 2 mediums only. So bolt will be in singles here in this one, okay. And numbers of bolt, so as we can see from this view, just a minute. See, from this view if we see, so we are providing cleat angle with the column over here with this angle, and over here also one angle will be there which we cannot see from this side, okay. So it will be like this, this one is this, while this one is this. So we are providing bolts in equal numbers on both sides. So for this one, bolts number must be in terms of even numbers, okay. So we can see the statement over here, when the cleat angle is connected to the flange of the column, bolts are always in singles here and numbers of bolt must be even, okay. So get back to the sum. Step number 2, see, connection between web cleat and flange of column. So first of all, let's take the column, just a minute. Over here in the data we have already calculated this one. Column mass has be 300 and thickness of flange. See, for this one we need to consider thickness of flange. Why thickness of flange? Because we are connecting cleat angle in the flange of the column, that's why thickness of flange is considered. While in case of the beam, we were connecting cleat angle in the web of the main beam, so we consider the thickness of web for this one. While in this case we will connect the cleat angle in the flange of the column, so thickness of flange will be considered, okay. So see, column, that is size with 300 and thickness of flange of the column is 10.6. Now let's calculate the shear capacity, VDSP. Formula stands for 45.3 for the single shear. Now as we have already seen in the theory, that bolt will be subjected to single shear, okay. So single shear's value is already there, that is 45.3 kilonewton. Put down the value over here, we will get VDSP 45.3. While talking about VDPB, bedding capacity, formula stands for 8000 into T. Now T stands for 10.6. Put down the value over here, 8000 into 10.6. We will get the answer 84.8 into 10 raised to 3 Newton. Let's convert it into the kilonewton, that is 84.8. Finally, bolt value will be minimum of these two value, okay. So minimum value will be obviously this one, that is 45.3. See, numbers of bolt. Numbers of bolt equals to total reaction divided by bolt value. Reaction is 150. It is given there in the data. Divide by bolt value. Say bolt value minimum of VDSP VDPB 45.3 and 84.8. We got these two values. So minimum will be obviously 45.3. Let's put down it over here. 150 divided by 45.3. I got the answer 3.43. Now while deciding the round figure numbers of bolt, so we have already seen in the figure numbers of bolt must be even, because we are going to distribute the bolts into equal manners on the both sides. So we must provide numbers of bolt in terms of the even numbers. So we will provide 4 numbers, okay. So provide two bolts of the bolt in two of both sides of the beam, like that. Okay, let's see it in the sketch. See, this one and this one, and thread of these two we can see over here side, in case of the side view, this one. Okay, let's calculate the length of this angle. That is obviously n minus 1 into pitch, that is pitch, and 2 times upper and lower, that will be n distance. Okay, let's see length of the cleat angle, n minus 1 times pitch plus 2 times n distance. Numbers of bolts are there, that is 3 minus 1 into 50 plus 2 times 8, 40. Answer is 130 mm. So we got the length of the cleat angle. And finally deciding the size of the cleat angle. So we've already discussed cleat angle is usually assumed as equal angle, so 90 by 90 is fixed. Okay, while deciding the thickness, okay, we should always take care that thickness of the cleat angle must be greater than thickness of wave of the beam, while thickness of flange of the column. Okay, so thickness of wave, that is I think 6.7, and thickness of flange of column was 10.6. so we need to provide greater value, the value which is greater than 6.7 and 10.6. Greater is this one, so I need to provide greater this one, so I will provide, we can say 12 mm. Okay, so you can see over here cleat angle size 90 by 90 by 12 mm and 130 mm long. Okay, and finally at the end you need to draw this sketch. This is your final answer. Say this one is my, just a minute, let me zoom out. See, this one is my column, you can see this one as well as this one. Okay, this one is the step number 1, in which we provide the cleat angle with respect to beam. Numbers of bolt were 3, while in the second step we provided cleat angle with respect to the flange of the column, that is numbers of bolt 2 on the both sides, we can see. Okay, and this one is a cleat angles notation 90 by 90 by 12 mm. Okay, so this is the second sum in which we connect the cleat angle, one with respect to beam and another that is with respect to column. Okay, so hope so guys you got the criteria clear about this one. Okay, thank you.